Well, thank you, and thank you for the introduction. And thank you to Conrad Clifford for sharing 100 years of commercial aviation. I actually thought that was a really beautiful story, and it put it in such a lovely way of where we're actually heading into the future of aviation. And I'm going to ask you a question. Who here is interested in the future of aviation? Yeah? Great. Because I know I definitely am, and I'd love to share with you the global Rotary outlook. What actually is happening and why it is happening as well. Now I'm going to use some slideshows here today so I can sort of talk through of actually a little bit touching on our history, because really the future is based on history. First, let me play a short video for you. Show you a little bit of that video and really where the future of aviation, really where we're going. But first of all, it does start from the history of aviation. And the first thing is that we've seen the ancient Chinese used to play with these little hand-spun toys that revolve rapidly as early as the early 1500s. We had the great Italian Leonardo da Vinci, who also used his mind to make drawings of what we know today as the helicopter. And it was actually his ideas and drawings and others that would follow that would work in theory, just would not be practical at that time. And for AgustaWestland, our history goes back 107 years. And it really is from the amalgamation of 3 companies, each boasting a long, rich history in production of aircraft. Now, it was Giovanni Augusta who flew the very first aircraft in 1907. And during the same time, Westland founders, Ernst and Percy Peter, were producing engines in Yeovil, and they were moving into aircraft production. Now, together with Augusta and Westland, they collaborated and moved into manufacturing rotary aircraft. And it was really during the 1960s, their first collaboration of the Augusta AB-47G. And over the years, Augusta and Westland have merged together under the name of AgustaWestland under the banner of Finmeccanica. So really that's just a bit of the history of us, of AgustaWestland, of 107 years. And we're here to talk about the 100 years of aviation. And the first thing is about the Rotary outlook. What actually is happening and why is it happening? What we already know, it is very much customer driven, based on technology, safety, and performances. Now, I just want to show you a graph here behind me, and this is really looking at the global outlook. What we can actually see is the increase of the civil rotorcraft market. So on the left-hand side, on that particular diagram, you can see from to now through to about 2020, we're going to see an increase of civil production of rotorcraft. On the military side, we can actually see there is a downhill, definitely decrease, and that's really due to the reduced funding by the government. But overall, when we combine both civil and military markets, we're looking at 23,856 new builds between now and 2023, which really is to the value of $247 billion. Now, with different aircraft, we have different roles, from corporate and VIP, oil and gas, emergency medical services, search and rescue, law enforcement, as well as utility. And for the military roles, we have the naval, utility, and combat. Now, what I'd like to really spend just a little bit of time talking about is technology, safety, and performance. We can see the next generation of avionics, and very much to reduce the pilot workload and increase the situational awareness. So you can actually see on that particular screen, it's a AW169 cockpit, neatly laid out, and we're seeing really the overlay of different systems like flight management systems, weather radars that actually can be configured into the one particular screen. So with situational awarenesses, we're seeing systems like synthetic vision systems, great for IFR flying. Things like ADS-B out, I'm sure most of you pilots are already very familiar with this, and this is one of the newer surveillance systems that runs at 1090 megahertz. And another great feature is the TCAS-2. Now the TCAS-2, a lot of you already use TAS. This is the traffic collision avoidance system. So not only does it show us where the other aircraft are, but also gives us options of rerouting around them as well. 4-axis autopilot, already commonly used by many. And the reason I wanted to point 4-axis autopilot is we're seeing in search and rescue where it really is being used at the moment for overlaying information or being able to do grid patterns when out at sea and searching for people. Another one of those features is auto hover, I should say. And auto hover is great for winching. We've seen, for example, in some aircraft, for us it's with 139s, but we see other OEMs using this, where we have a small remote device like this, which the crew in the cabin are able to move the aircraft exactly to the required position. An enhanced vision system. Some key system again into the future is, once again, it's an external camera that is mounted on the bottom of the aircraft, and it allows us very much to be able to have better visibility through bad weather, cloudy days, fog, and nighttime as well. Another system that I just want to point out while we're talking about where the future is heading is HITS, Highway in the Sky. And this is great. It actually allows us to fly through skyway boxes. Very good for when we're flying through unfamiliar areas. And it really just shows us a great picture, being able to see through where we're flying in like a tunnel sort of through green boxes. Terrain and awareness warning system. Now this provides a terrain sounds of an audible warning, which when the helicopter is approaching very close to terrain or structure. And you can see on the particular picture behind me, it goes in different color coordination, so it actually allows us to see at what altitude we're coming into. Another one really, when we're talking about new technology, it really is becoming at our fingertips. It is about increasing system performances, enhancing effectiveness of crew interaction, and common interface of management of the avionics. So really what we're seeing is very much it is becoming a touchscreen where we are able to actually use everything centralized through that particular screen. Now, common cockpit concept, I wanted to add this in. This is something Augusta Westland has come up with, and this is brilliant for pilots to be able to move between different aircraft. So what they've actually designed is the AW169, AW139 and AW189 are basically designed with a common cockpit concept. So this is for the ease of training, maintenance, as well as support as well. So it just makes it a little bit more easier to go between each aircraft. Now, connectivity. I'm sure most of you are already familiar with map service, which we use for all our map and data. Now we have a software called Skyflight, which allows us to take to upload all of our maps onto Skyflight. And whether you're at home planning your flights, or you might be at a coffee shop on your iPad, you can plan all your flights so that when it comes to coming into your aircraft, all we need to do is either using Wi-Fi or just a small USB to upload all the flight data into your aircraft, and you're ready to go. Another feature, again, of looking into future and what already is being currently used is things like for health and usage monitoring systems. So once again, from an aircraft, you can see on the diagram, is the actual information, all the maintenance data is uploaded onto our computer, and that is synced through the HeliWise. And then HeliWise is a web hum service which is continuously monitoring this data. And this particular actual software and maintenance data is being used on the 139s, and it's actually had a 96% available rate. So it really does keep an eye continuously on the aircraft's performances. So we've really talked about technology, and pretty much most of that technology has been based around safety, because really safety is at the centre. And we really need to pay, I guess, a lot of time to be able to invest into the future of having safe aircraft. So things like the regulatory requirements for Europe, you've got EASA for Performance Class 1 Category A, and here in New Zealand with Performance Class 1. And these are all amendments made to FAR and JAR Part 2729. Now this really is customer driven. It's coming from the offshore and gas producers, but also emergency medical services who require flying into built up areas and do need to have that Performance Class 1 capability to be able to fly away safely should an engine fail. Now that particular diagram here is, we touched on OGP. The offshore oil and gas producers are very much setting the benchmark of the future. So really not OEMs like AgustaWestland are manufacturing or making new technology. We're really making sure that we're designing what is required by the offshore oil and gas producers. So that particular diagram there you can see is the 189, and there is actually industry-driven seating layout. So those of you that are already in the industries are aware that you can only have 2 seats maximum before actual exits. And OEMs like AgustaWestland are already anticipating future requirements of producing, for example, larger windows for egress. So we can see the actual dimensions that are required currently. We're already manufacturing larger windows for being able to safely exit the aircraft should incidents require. Gearbox technologies. Already current rule is to have a 30-minute dry run capability. And with AgustaWestland, we design and manufacture transmissions in-house. And it allows us to really spend the time to invest to make transmissions that can even do more than that. The 189, which obviously is being used for offshore reasons, we have 50-minute dry run capability on that aircraft. And we're going to see into the future, not just 189s, but in many more aircraft designs, including the 169 going into things like 50-minute dry run capabilities. This is one of my favourite ones, the obstacle proximity LiDAR system. Now this particular system measures the distance in every direction from rotor discs. Now when I was in Italy, I saw an incredible video which was back in Switzerland. They were doing a rescue to pick up a patient who fell off a cliff. And if those of you have been to Europe or New Zealand's pretty much the same beautiful scenery where you have very narrow roads on a cliff side. And I saw a 139 was able to land on this cliff side by using the LiDAR system. And the word LiDAR is from light and radar. So it's actual lights, lasers that are bouncing back, giving the pilot, you can see the little picture in the cockpit, which can be on your PFD or MFD screen, come up with actual measurements or distance of close proximity to land. So really great. It also has oral alerts to let you know of how close you actually are. So really safety is at the centre. Safety drives continuous development of aircraft. It's the key to a safe future in aviation through safety management systems, improved training, advanced systems and equipment using health and usage monitoring systems, and mission-specific safety equipment including avionics and to avoid controlled flight data into terrain. And of course, we night vision devices that we already use now. So when you look at technology, safety, this is where really the future is heading. It's based on performance, having increased payload, having increased range, as well as speed. So we can really see the future of the rotary industry is to be able to have better, faster, and more efficient aircraft that we're looking into. Something else I'd like to touch base on, and I didn't really speak about this, but is unmanned rotorcraft, and we saw Conroy Clifford actually speak about this a little bit. We're going to be seeing a lot more of these in the future. We recently demonstrated one to the Italian Ministry of Defense, and another one is environmental response. That picture right here is the Project Zero demonstrator. It was produced in 6 months, all electric, and it does fly. And so really what we're looking at is being able to minimize noise footprints, having low environment impact, and low drag, low fuel burn as well. So overall, when we're looking at technology, safety and performance as a way of future, is really the way we want to progress. About 24,000 new builds of aircraft will be produced between now and 2023, which we spoke of. And the other thing I wanted to mention is the offshore and oil and gas are very much setting the standards, but we're going to see those follow through down to all operators that will actually see the benefits come across the board. So really what we're looking towards is a good, safe future together. Thank you.